Hello everyone. Today I wanted to talk to you about some useful command line tools and Python packages that are used for point cloud processing. I would like to point out that there is a nice fast viewer of point clouds called Displace that is very useful for viewing point clouds and making a quick first assessment. It is not as feature-rich as Cloud Compare, and it doesn't allow you much interaction, but it's a really nice fast viewer for even larger point clouds. So I strongly suggest that you go to the web page and either get the installer or get the source code from the GitHub site and install that little quick viewer that again is very, very simple, but allows you to view LAZ, PCD, PLY, and other formats as point clouds. It's very useful for a quick assessment. Um, in terms of installations for using Python, there are several packages that are very, very useful. The first thing that I wanted to point out is that for using Open3D, you definitely want to use Python version 3.9 and not the most recent one, 3.10. The other packages all work with different Python versions. I strongly suggest to go for 3.9 at the current point until Open3D had been updated and fully made compatible with Python version 3.10. You can get these packages installed via Conda or Anaconda if you're not fully familiar yet with Python, or if your experience is not too deep with Python. I strongly suggest that you use the Anaconda environment. This is a commercial environment that is supported by an open source community, and you can download several installers, particularly for the Windows and for the Mac realm. You can install the large installers, and here again gets a 64-bit 3.9 installer that also already contains many of the packages. If you are If you have Anaconda installed, you can open up the Anaconda shell. And within the Anaconda shell, that interactive terminal environment, you can, for example, add another channel for installation. So this is something you would copy and paste to the Anaconda shell. And then you can install the required packages. So this is this snippet here. So I actually added this channel that is being added to the front. So all the packages are first searched in that channel. And then we are creating a new Python environment or a Conda environment. This is called py3_pc, and PC here stands for point cloud. So this create minus y, the create minus n is the name of that environment, and minus y just indicates that all questions are to be answered with yes. Then you define the Python version, and then we are going through a couple of packages that I'm not mentioning in detail here, but that we will explore during the tutorials and Jupyter walkthroughs that we work with. I want to point out that at the end, you activate that install environment. This may take actually a few minutes, and I strongly encourage you to do this before we start. You need to install some additional packages through the pip installer once you have activated that environment. Usually you don't really mix Conda and pip, but in this case you want to get Open3D and lastpy and last_zip installed to be able to read LAZ or LAS files. Last but not least, once you have this environment installed and activated, you can add that environment to your Jupyter Notebook environment, meaning that if you like to use Jupyter Lab or Jupyter Notebook, you need to tell Jupyter Lab, Jupyter Notebook that you would like to use that Conda environment, and that can be done by this command that then installs that specific environment into the Jupyter Lab kernel. We are going to look at that in one of the next tutorials. For Linux and Mac users, it's pretty much the same, with the difference that I usually, when I'm on a Linux system, I usually don't get the entire Anaconda package. I get something that is called Miniconda. Miniconda is just a command line driven environment, and so without the graphical user interface. And that's something that can be installed in that fashion. So follow those suggestions that come here when you call that shell file. And you do the same by adding that Conda Forge channel, and then you install the same packages from the Conda environment that allow you to do some of the um, tutorials, or pretty much all tutorials that we are working with. So this part is similar to the Windows environment. For those of you who are already familiar with Python and maybe have their own virtual environment and only use with pip, I have included an additional outline here how this can be done and installed, and I make the assumption that you know what you're doing when you're working with pip. So I'm just providing the commands here, and then you can install this by yourself. Last but not least, I wanted to point out that when you are interested in working with Python, it's useful to have a powerful editor. We are mostly going to use Jupyter Notebook and Jupyter Lab for the tutorial sessions, but I'm not using Jupyter Lab or Jupyter Notebook for programming my own codes. I usually work with Spider, but there are other alternatives that provide an interactive environment when you're working with Python. So Spider is one of them. You can also use Atom if you're familiar with that editor. It's a nice plugin that exists there. But there are several other examples. I'm just pointing out that you may want to look into installing an editor if you're seriously considering programming with Python. Otherwise, the Jupyter Lab and Jupyter Notebook environments that are being installed, by the way, with the commands up here. With these commands here, you are installing the Jupyter environment. You'll be completely, fully all set for that tutorial here.